How does cocaine addiction change the brain? Imagine your brain as a busy city with roads and signals that keep everything running smoothly. Now picture cocaine entering that city like a sudden rush of traffic that causes chaos. When someone uses cocaine regularly, it causes big changes in how the brain works and looks. These changes happen in parts of the brain that handle feeling good, making decisions, and forming habits. That's why stopping cocaine can be so hard, because the brain has been rewired in ways that make cravings and compulsive use stronger. Cocaine affects a key chemical in the brain called dopamine. Dopamine is like a messenger that tells you when something feels rewarding or pleasurable. When cocaine is used, it blocks the reuptake of dopamine, which means dopamine stays in the space between nerve cells longer than it should. This causes an intense feeling of euphoria or a high. But this also messes up the normal signaling in the brain, making it harder for natural rewards like food or social interactions to feel satisfying. Over time, the brain adapts to these high dopamine levels by reducing the number of dopamine receptors or changing how they work. This means the person needs more cocaine to feel the same high, leading to increased cravings. Certain parts of the brain change more than others. The nucleus accumbens, which is a core part of the brain's reward system, develops more dendritic branches. These are like extra roads that make the influence of other brain areas stronger, especially those involved in memory and emotion. This can cause powerful drug-related memories and cravings to form. The prefrontal cortex, which helps with impulse control and decision-making, also changes. It becomes less able to evaluate the consequences of actions, so resisting the urge to use cocaine becomes much harder. The dorsal striatum, a part of the brain involved in habits, shows molecular changes that push the user from voluntary use to compulsive, automatic behavior. Other regions like the amygdala and hypothalamus also change, affecting stress responses and motivation, which can make cravings worse and influence physical effects like appetite and energy levels. On a genetic level, cocaine influences gene expression and molecules called microRNAs that control nerve cell growth and signaling. These changes can last 4 months or even longer after stopping use, which explains why cravings can come back long after someone has quit. Understanding these brain changes shows us why cocaine addiction is a chronic condition. It's not just about willpower but about real alterations in brain structure and function. Treatments need to target these changes, often combining medication, therapy, and strategies to weaken drug memories and reduce cravings. This way, recovery becomes more manageable and the chances of relapse decrease.